8M3 lesson 6. This is dilations on the coordinate plane and how to perform a dilation on the coordinate plane. I'm going to start by reminding us of the building blocks that we need to understand this lesson fully. The fundamental theorem of similarity along with the definition of dilation. Then we're going to take that forward to show you how to dilate any point on the coordinate plane using triangles. And then I'm going to give you the final formula, which is the whole point of the lesson, which makes everything easy. But if you just go to the formula and memorize it, it's not going to maybe stick in your mind as well as understanding the concepts. So let's get right to it. Let's go to our building blocks and let's understand those and then move forward. So the fundamental theorem of similarity along with, so this is the first key point that we're going to use, and then dilation, the definition of dilation will give us what we need to know. So the whole key to dilation, remember, is if we want to dilate this point, we're going to talk about dilating this point, A. We're going to dilate point A, and we're going to give it the outcome will be a point A prime. Now we know from everything we've learned that that point will be on this line. Well, let's get So the dilation point A prime will be somewhere along this line in extending out infinitely along, well, actually this is a ray, right? Along this ray. Okay, and the distance that point A is dilated along this ray has to do with our with R, which is our scale factor. If R is less than 1, if R is between 0 and 1, then it will be somewhere in here. If R equals 1, then A prime will be right on top of A. But if R prime is greater than 1, then A prime will be out here somewhere, right? So that's all neat and dandy. That's our definition of dilation. Now, what we learned in the most recent lesson was that we can't always figure out, well, if R is 3.5, let's say R is 3 halves, or which equals 1.5. We don't know how to go 1.5 times down this ray to find, it'd be somewhere around here, around here, around here, but we don't really know where that point is. We can't find 3.5, 1.5 times exactly along this line. So what we do is we use our fundamental theorem of similarity. And so so just bear with me. So then what we do is we pretend if we drop a line down straight here, then any other line that is parallel to that line will contain 2 points that are both scaled from A and B. Okay, so if I drop a line down from here to here, and if this line, we're just going to put another thing, A prime and B prime right here. If these two lines, if they're parallel, then A dilated to A prime and B dilated to B prime both have the same scale factor. So in other words, whatever this distance divided by this distance is the same as this distance divided by this distance. So if these are parallel lines, and if this is 2 times further from A to A prime, then B prime is 2 times further than B to B prime. Okay, so that's what it says, if these two lines are parallel. Now, let's just erase all this, and let's get back to the question at hand. We want to know what is 3.5 times or sorry, 1.5 times, or 3 halves the distance from here to here. Well, again, I don't know what it is along here, but this one is really easy to figure out. Let's go back and draw in this parallel line here, or this straight up and down line here. And you'll see why I do this in a second. So I know that this distance here is 4, right? Because I can find things straight vertically and horizontally on the coordinate plane. These are easy to figure out. Diagonals are hard to figure out. So because this is 4, I can now say I can find 3 halves of that 4. And I can find that that's 6, right? 3 halves, that's my scale factor. I'm going to scale B, point B to scale B to B double to point B prime. All right, so we're going to scale, or we're going to dilate, dilate B to B prime, and we're going to use a scale of 3 halves. And that's easy to do. 3 halves times 4 over 1 equals 12 halves equals 6. So B prime is here. Okay, so now I can draw a line that's parallel to AB from B prime. And again, that's an easy thing to do. It's gotta be a vertical line. And there you have it. So this point up here, and let's make the point in green to be our final answer, must have an x-coordinate of 6. Right? Because B prime is 6, 0. Right? So we've used our fundamental theorem of similarity, our definition of dilation, to make it easy for us to find the x-coordinate of our dilated point, our dilated A, our dilation of A. 3 halves of A, we dilate A, we come to here. And we know our x is 6, which is the same thing as our dilation scale factor times our original x-coordinate. So our dilation factor times our original x-coordinate equals our scaled x-coordinate. We can draw a similar triangle over here, and I won't do that right now. And we can show you that the scale factor times y is equal to our new y-coordinate. Okay, so then what would that be? Our y-coordinate is 3. So 3 halves times 3 is equal to 9 halves, which is 4.5. Right? And that looks about right. So this is 4.5. And that is our answer. We'll get to the general formula. I'll draw it out neatly for you on another slide. But this is the whole idea. We're building on some very powerful building blocks to learn how to scale any point in the coordinate plane. And we can use this to further create dilations of geometric shapes. And we'll get into that later as well. So let's go to some of the examples here in the chapter. We say 0.79, so this is 0.79, is dilated from the origin by a scale factor of r equals 6. So what are the coordinates of point A prime? Well, we know from our definition of dilation that the point has got to be somewhere on this line. So let's draw that line here. So we know it's somewhere on this line, and then we can draw our little mini triangle, the one that's, parallel or drops down to our x coordinate. And so what is this x coordinate? What is this x coordinate? Well, it's 7, 0. And let's just label this point B. Now, if we're going to now we dilate point B all the way out here, and then we go back and figure out what point A is, right? That's the whole trick. It's easy to dilate points along the x and the y axis. So 6 times this distance here, if this distance is 7, 6 times that is 42. Right? 6 times 7 equals 42. So this line here is 6 times further. And let's just draw that line in, like, say, yellow. Now, we're going to take that upwards. And so we're going to use our fundamental theorem of similarity and say, well, if this line, well, let me draw in our letters here. So this is B prime. This is B prime. And this is A prime. I don't know the coordinates of A prime, remember, but I do know the coordinates of B prime. It's 42, 0. So if this line here is parallel to this line here, then these are both vertical lines, and a vertical line that goes through this point at 42, this must also have an x coordinate of 42. Now let's do the same thing with our y-axis. We're going to use the fundamental theorem of similarity, and I told you I was going to show you that. So let's show you that here. And so this point here, and we'll do this one in we'll do this one in green. So this here is 0, 9. And let's call this, make it bigger, 0, 9. And this is point C. So somewhere up here is C prime. Well, if this is 9, then 6 times 9 is 54. Right? This is 9. If I'm going to scale C with a scale factor of 6, I got to go to 0, 54. And that's my C prime. So if this has, and so now let's draw our line here that's parallel. So this is a horizontal line, and this is a horizontal line. So if I scale point C to point C prime by a scale factor of 9, then A scaled to A prime, these must be scaled by the same factor, by the fundamental theorem of similarity. So if this has a y coordinate of 54, then this one has a y coordinate of 54. And so our answer is 42, 54. And that is the same thing as our original point, 7, 9. You multiply this by our scale factor of 6, and you get 42. And 9 times 6 gives you 54. Right? So the shape, drawing all the shapes helps you prove dilations in the coordinate plane and how we calculate them. But the formula, again, is x to y. If we dilate that to, x prime, y prime, using a scale factor of 6, our answer is 6x, 6y, or 6 times 7, 6 times 9. Now let's do a different example. Oh, let's happy cat that for sure. Let's happy cat, and we can spin the happy cat. And this is the whole key to the lesson. We're going to do it one more time, and we're going to do it with a shrinking example. So again, let's look at our key pieces of information that we need to know. Let's read the question. Point C is at 6 comma negative 2, right? 6 and negative 2. From the origin, we're going to scale from the origin. So that's where we got to, so if we're scaling from the origin, we got to start at the origin and draw our line through here. So our dilated point is somewhere on this line. And the scale factor is 3/4. So 3/4 is less than 1. So this is a what? A shrink or a grow? For those of you at home that said shrink, you are correct, and I will give you a little happy cat. Now we have to figure out what's 3/4 of the way along this line. We can't count 3/4 of the way along diagonals on a coordinate plane very easily. But what trick can we use? Well, we can draw our triangle. And we can say, well, this point here is 6 comma 0. And now it's easy for us to find 3/4 of the way along this line. Well, if this is 6 comma 0, 3/4 of the way along this line is 3/4 times x, which is equal to 18/4, which is equal to 9/2, which is equal to 4.5. So here is our point. Now, we're not interested in exactly what this point is. We want to know what this point is. So let's go back and label our points. So if this is A, we're going to call this point B. This is B prime, and this is A prime. So A prime must have an x coordinate of 4.5. What's the y coordinate? We don't know yet. So let's do that one now. And we'll do that with a similar triangle in the other direction, and we'll make that one be orange. So we come over here and we find our y coordinate is 0 comma negative 2. And we got to find 3/4 of the way along this line. Well, 3/4 of the way along this line is calculated. If that's 0 and that's negative 2, we have to go 3/4 of negative 2. Right? 3/4 of this number will give us how far down is 75% of the way, or 3/4. 3/4 times negative 2 equals negative 6/4, which equals negative 3/2, which is negative 1.5. So it's right here. So if this was point C, this is point C prime, and that's at 0 comma negative 1.5. So if we take this line over here, we now have two parallel lines. So if this was scaled, if this is scaled by 3/4, then going from here to here is scaled by 3/4 by the fundamental theorem of similarity. And if this line is parallel to this one, then it's a horizontal line. And so this must have the same, everything on this line has the same y coordinate. So negative 1.5. So our answer is 4.5 comma negative 1.5. Now you could have also just figured that out. You wouldn't have to do any of this. Well, let's happy cat that. Happy cat. Let's celebrate our happy cat that we got it. But you wouldn't have to do any of this if you would just use the formula that says that x, times r equals our x prime, and our y times r equals our y prime. So our x is 6 times 3/4 equals 4.5. And this is -2 times 3/4 equals -1.5. And so that's our x prime, y prime. And this is the way you do it formulaically. This is the way you may have to show it or prove it on a test, but this is the key. This is the formula. Now, good. We will move, big happy cat that. And we are going to move now into homework help, which is the last. Oh, no, let's just go to the lesson summary real quick. So the lesson summary is to dilate any point xy about the origin. If you dilate it about another point, it doesn't work, but you almost always dilate about the origin on the coordinate plane with scale factor r. The dilated point is r times x, comma r times y. So let's use this. We're going to use this information, use this lesson summary for homework help. Okay, so let's go to the homework help, which is what you all came for. So here's an example homework problem that I want you to try on your own. We're going to dilate triangle ABC from the origin using a scale factor of 3/2. So here's my hint. Scale each vertex by itself. So you have three dilations, then draw final triangle. So that's my hint. Now I want you to pause and try. Now I assume you're back, and we're just going to do each one of these using our formula. So we're going to take our x coordinate here. We'll start up here with B. X prime equals r times x. Let's just write it rx, which is r times x, and y prime equals r times y. So that's 3/2 times 4, and this is also 3/2 times 4, because that's our y, and that equals 6, 6. So this is our x, again, our x prime and our y prime, which constitutes b, b prime. So 6, 6 is right here. So that's our b prime, 6, 6. And it doesn't matter if this is a triangle or a quadrilateral. You're going to do it the same way. You're just going to scale each point by itself. So C, we have our x prime is equal to our scale factor, 3/2 times -4, which is equal to -6. And our y prime is equal to 3/2 times -2, which is equal to -3. So here we are, -6. This is our C prime, which is -6, -3. Okay, and now our A prime is 6 x prime, 6 times 3/2, which is 9, and our y prime is -4 times 3/2, which is equal to -6. So 9, -6. That's A prime. So let's draw our final triangle. Yeah, we'll just go ahead and leave it in green. Maybe a lighter green. Never really used that color. So let's draw that guy. And there is our scaled triangle. So if you see, it's bigger, it's the same shape. If I ask you anything about the angles, you would be able to tell me that these angles, this angle is the same as this angle, and this angle is the same as this angle, because dilations maintain angle measures. And if I ask you about, here, let's ask a bonus question. Here's a bonus question. Well, let's give you your happy cat. Here's your happy cat for getting that right. But I'm going to ask you a question, and this is going to help put it all together. How much longer is A prime B prime? A prime B prime than AB. So how much longer is this guy multiplied by, well, what did I have to multiply AB by to get to A prime B prime? How much longer is it? How many times, not how much longer, how many times longer is A prime B prime than AB? Well, the answer is 3/2. It's 3/2. It's the scale factor. And that's by definition of dilation. So it has to be. Angle measures are maintained. Sizes, relative sizes, are figured out by multiplying by the scale factor. All right. Well, hopefully this was a useful lesson for you. Oh, sounds like it was. Stick with it. Everything that you're doing on the homework problem set is based on using this formula of scaling, dilating, scaling each point, using R, multiplying it by X and Y to get your new X and Y coordinates, whether they're shrunk or whether it's grown, and then drawing your final shape. Good luck, and we'll see you next time here on Dave Lipscomb's Math